Today we're going to evaluate a limit analytically. We're going to take the limit as x approaches 0 of 1 minus the cosine of x over x. Generally, this limit is given to you along with the limit as x approaches 0 of the sine of x over x as a theorem, and you're actually told that this limit equals 0, this particular one here. And while that is true, and I definitely encourage you to employ that theorem when this pattern arises within other limits, but since this limit right here you actually do have the tools to evaluate it analytically, I think it's a good exercise, and also it shows you a common technique that we use when evaluating limits, particularly of this form. But it actually uses that technique with trig, which you might not have seen. You might see the technique that I'm speaking of when referring to things with radicals in them. So anyway, the best clue I can tell you to start, well, first thing we need to look at the form of this limit. And the limit as x approaches 0 of 1 is 1, and as the x approaches 0 of the cosine of x, and we can make ourselves a little sketch, and we can look at the basic cosine graph. Sorry, it's not very good, but this is basically all I'm really concerned about right here, and we can see that it approaches 1. And then we can actually make ourselves a little sketch of the denominator as well, and draw ourselves a little identity function, and we see that as it approaches 0 from both sides, it's 0 as well. So we say that this limit has the indeterminate form of 0 over 0, which isn't 0, it isn't anything, it's indeterminate. Some people say undefined. It doesn't really matter, it's indeterminate, meaning you can't determine what this limit is at this point. But you can change the appearance of this and move it around and see if you can't manipulate it a little bit, and you can evaluate this limit. So what we do, and I'm just going to recopy it since I've drawn those little graphs there. The limit as x goes to 0, 1 minus the cosine of x over x. The best thing I can tell you when looking at something like this is I see there's not much I can do to the denominator, it's x. 1 minus the cosine of x, though, that minus kind of tells me something. The fact that there's two terms in the top, and hopefully you're up on your trig and you can remember basic identities, and that you might even could look into the future. But the best thing really, that if you weren't up on your trig and you didn't see it immediately, would be that you have an expression on the top that is the difference in this case of 1 and the cosine of x, which anytime I see that, anytime I see 1 minus the cosine of x, 1 plus x, 1 plus the square root of x, 1 minus the square root of x, etc., etc., I think maybe multiplying the top and bottom, the denominator and the numerator, by the conjugate of the numerator is probably going to be the best course of action. At least it won't hurt to see if something pops out when I do it. So that's the best suggestion I can give you of why I chose to multiply by 1 plus the cosine of x over 1 plus the cosine of x. When we do this, we're going to go ahead and expand or multiply out, distribute out the numerator, numerators in this case, but we're not going to expand the denominator. We're going to leave it in factored form. So when we do that, the limit as x goes to 0 of 1 times 1 is 1, 1 times the cosine of x is positive cosine of x, 1 times the negative cosine of x is negative cosine of x. The middle term cancels out. We're left with negative cosine times the positive cosine, which is the negative cosine squared of x. Put that a little bit more. And then the denominator is just, as I said, don't expand the denominator, leave it in factored form. X times 1 plus the cosine of x. You might be, well, the form is still 0 over 0, and you're right in this case, but we need to change it a little bit. And hopefully you remember the Pythagorean identity of the sine squared of x plus the cosine squared of x, equals 1. If you don't know that, I encourage you to learn it. It's not just important in this course, it's important in all calculus courses. I can't tell you how amazingly useful that identity, even when I thought I'd beat it to death and used it all I could, it pops up in some really interesting ways, actually. But anyway, if we were to solve this for the sine squared of x, we would get the identity sine squared of x equals 1 minus the cosine squared of x. And that's what we have in this numerator here. So we can rewrite this limit as x approaches 0 from both sides of the sine squared of x over x times 1 plus the cosine of x. At this point, we kind of, I guess you could kind of say that we still have the form 0 over 0, but we can manipulate this a little bit. We can break it up, and we can use the property of limits that says that the limit of products is just the product of the limits. So therefore we can kind of break this up a little bit, and hopefully we're going to use the other fundamental trigonometric limit, the theorem that you're given usually alongside with this one, that is a little bit more difficult to prove. The limit as x approaches 0, I'm going to pull that sine of x, one of the sine of x of the numerator out, I'm going to put it over x, times the limit as x approaches 0 of the other sine of x over 1 plus the cosine of x. This limit right here, hopefully you know that this limit is 1. You're given that in a theorem, memorize it, use it. The way I've seen it proved is geometrically, which is a little bit difficult to do on your paper every time you see it. I would think that it would be a lot easier. Just remember, the limit as x approaches 0 of the sine of x over x, and the reciprocal of that is true as well, is 1. Anyway, we'll go more. You will use this particular limit, that theorem, over and over and over again. Now we look at what the limit as x approaches 0 of the sine of x over 1 plus the cosine of x equals. And as x approaches 0, the sine of x, the numerator, is equal to 0. And as x approaches 0 of 1 plus the cosine of x, well, as we talked about before, as x approaches 0, the cosine of x, we get a 1. 1 plus 1 is 2. Well, now we have 1 times 0 over 2 is 1 times 0 equals 0, which is the theorem that we're given in our text, usually alongside of the limit as x approaches 0 of the sine of x over x equals 1. So just a brief recap, basically what we did is we used, in order to evaluate this limit, we multiplied the numerator and denominator by the conjugate of the numerator. We simplified, we employed Pythagorean identity in order to change the form, and then we used properties of limits, that is, that the limit of products is the product of the limits, in order to evaluate this limit and actually prove analytically that the limit as x approaches 0 of 1 minus the cosine of x over x equals 0. Again, I encourage you to memorize this and this, what they equal, in practice, because they will pop up inside of other limits, and it'll be a lot quicker for you if you don't have to go through this process.